Welcome. The purpose of this presentation is to assist district-level and school site teams in the design, implementation, and evaluation of functional assessment-based interventions using single-case design methodology. Visual analysis assists educators and therapists' evaluation of the effects of the intervention on student outcomes and for data-based decision-making. The purpose of this slideshow is to guide you through interpreting graph student outcome data through visual analysis. Student outcome data may focus on reducing a problem behavior or increasing a pro-social or academic behavior. The guidelines presented in this process are a guide and should not be viewed as absolute or inflexible rules for interpreting graphic data or making phase change decisions, but as general guiding principles to help inform and support educators' phase change decision making. Make sure to consider ethical issues as well when making decisions about when to make phase changes. In functional assessment-based interventions, target or replacement behaviors may be graphed. It is often the case that the replacement behavior is the graphed behavior in an effort to focus on the pro-social behavior. In this guide, we refer to three basic properties of data that are analyzed when conducting visual analysis for decision-making. These are level, trend, and stability. On occasion, we will introduce the notion of descriptive statistics to complement your visual analysis, specifically mean, standard deviation, slope, and standard error of slope. Graphing data provides a means of organizing the data you have collected, and it creates a picture that allows you to determine the effect of the intervention on the behavior of interest. Graph data are easily shared with educators, students, and parents, and show the student's progress in each phase pictorially, rather than only describing observed changes in words and numbers. In this guide, we focus on one single case research design, ABAB, or withdrawal design. Line graphs are the most commonly used graphic format for presenting data collected using a single case methodology. First, student outcome data, or the behavior outcome of interest, are converted to frequency, rate, percentage, number of intervals, or length of time, such as seconds, minutes, and hours, and is represented on the y-axis. And the unit of time, such as date, session numbers, or probe numbers, are represented on the x-axis. Then, performance is plotted as a single data point representing the data collected during that unit of time. Data points in each phase are connected with a line to show the behavioral pattern in a given phase. Phases or conditions such as baseline or intervention are labeled and separated by phase change lines. Data points are not connected by a line between phases, as you see in this example. In an ABAB or withdrawal design, the behavior of interest is measured without the intervention phase. In this example, A1 represents baseline, current practices in place, while A2 represents a withdrawal of the intervention, such as return to baseline practices. In other phases, the intervention is in place. In this example, B1 represents the first introduction of the intervention, while B2 represents the reintroduction of the intervention. Using visual analysis, we can determine the occurrence of the behavior of interest when the intervention is and is not in place. This is how we determine if a functional relation exists between the introduction of the intervention and changes in student behavior. In other words, does change in behavior only occur when the intervention is in place and not when the intervention is absent or removed? It is also vital to collect information on treatment integrity. This information tells us the extent to which the intervention was implemented as designed. We cannot draw accurate conclusions about student performance unless treatment integrity data are collected. We cannot simply assume that all intervention components are in place. We need to collect treatment integrity data to be sure. In this guide, questions are posed to help you better understand the use of level, trend, and stability for decision making, helping guide phase change decisions to test the effect of the intervention for this student. The first question to consider is what direction is the therapeutic or desired direction of the behavior? That is, which way do you want the behavior to shift? Do you want it to increase, decrease, or become less variable? The way you would like it to go is referred to as a therapeutic trend. The way you do not want the behavior to go is referred to as a counter-therapeutic trend. Sometimes you want to increase the behavior of interest. Consider a student whose target behavior is off task. Perhaps you want to measure or monitor time on task, the replacement behavior. In this example, you want to increase the student's time on task. In other words, the desired or therapeutic direction is for students' on-task behavior to increase. Other times, you want to decrease the behavior of interest. Consider a student whose target behavior is talking out of turn, and you want to decrease the frequency or rate of talking out of turn. In this case, the desired therapeutic direction is for the student's off-task behavior to decrease. Elements for possible consideration for using visual analysis to guide phase change decisions are number of data points plotted within a condition, number of variables changed between adjacent conditions, level stability and changes in level within and between conditions, trend direction, trend stability, and changes in trend within and between conditions, and percentage of data points in one condition that fall within the range of data plotted in an adjacent condition. To learn more about single case design, we recommend 2 resources: Single Case Research Methodology, Applications in Special Education and Behavioral Sciences by David Gast and Jennifer Ledford, published in 2014, and Applied Behavior Analysis by John Cooper, Timothy Heron, and William Heward, published in 2007. In the next section, we define level, trend, and stability, and offer guiding questions for you as you examine student outcome data. First, we introduce level. Level is the mean, average score of performance for the data within a phase. When examining level, you look at the overall magnitude of student performance. That is my student's behavior low, moderate, or high? The 3 illustrations presented here are all examples of data from the A1 phase baseline condition, meaning regular current practices are being used and the intervention is not in place. In the first example, blue, baseline levels are averaging 21.7 units as indicated by the mean score of the phase. This is relatively low level on this scale of 0 to 100. In the second example, yellow, baseline levels are averaging 48.7 as indicated by the mean score of the phase. This is relatively mid-level on this scale. In the third example, red, baseline levels are averaging 73.7 as indicated by the mean score of the phase. This is relatively high on the scale in comparison. Additionally, the standard deviation can be calculated and used as additional information with your visual analysis of level and stability. Depending on behavior of interest, that is the student's outcome measure being graphed, the level that warrants the need for behavioral change will vary. For example, low level of student engagement might warrant an intervention, whereas a behavior you're trying to decrease, such as disruptive behavior, would be evident by a higher level of behavior. When examining level, notice if there are changes in level within a condition. In this illustration, the phase began with 4 data points at a relatively low level. Then, around the 5th data point, there is a rapid rise with the final 4 data points at much higher levels. This shift is a good indication that something is changing within the condition. If this change in level occurs, ask yourself, what are you not accounting for? Or in other words, what could have changed in this condition that I did not have control over? A frequent level pattern I have noticed in my work in schools is the Monday through Friday pattern. Consider your own level of productivity, motivation, or engagement. Does it shift from the beginning of the week to the midpoint on Wednesday to the end of the week on Friday? How about your students' patterns? Here is an example of an immediate and substantial change in level across conditions. When examining level across conditions, it is often worth noting if the change in level was immediate or more gradual. In this example, there is an immediate change in level. As you build fluency in designing, implementing, and evaluating functional assessment-based interventions using single-case design, consider whether a change in level is immediate or gradual, with an increasing or decreasing slope. Slope is addressed in greater detail in the next section regarding trend. The descriptive statistics, mean, and standard deviation can be calculated and used to facilitate your visual analysis of level. You may use function capabilities in Excel to efficiently calculate mean and standard deviation. Next, we introduce trend. Trend is the overall direction or slope of a data path. Trend refers to the rate of increase or decrease of the best fit straight line for the outcome measure within a condition. When examining trend, look at the overall direction that the student's performance is moving. That is my student's behavior increasing, decreasing, or staying the same, flat? In the first example, blue, visually the student's performance is increasing, which is also indicated by a positive slope of 7.48. In the second example, red, visually the student's performance is decreasing, which is also indicated by a negative slope, negative 6.45. In the final example, yellow, visually the student's performance is flat, that is a zero trend, which is also indicated by a small value for slope, negative 0.30. In these examples, we have supplemented the visual analysis of trend with slope and standard error of slope, which tells you how close the data points are to the slope, or in statistical terms, the regression line. These statistics are supplemental information and can be used to complement your visual inspection of trend. When examining trend, look for any changes in level within a condition. In this illustration, there are three overlays: an orange trend line with a relatively flat or zero trend, a decreasing blue trend line, and an increasing purple trend line. When asking yourself if there is a change in trend within conditions, it is important to consider the desired or therapeutic direction of the behavior of interest and whether or not the intervention is or is not in place, based on condition and treatment integrity data. Here is an example of an immediate and substantial change in trend across conditions. In A1, or baseline, the outcome measure was occurring at a relatively stable and flat trend between the 70th and 80th percent range. With the introduction of the intervention, we have one possible path that is increasing, as illustrated with the purple trajectory. In the second illustration, we see a blue trajectory with a decreasing trend line. When asking yourself, is there a change in trend across conditions, it is important to note the desired or therapeutic direction of the behavior of interest across the phase change, and note which condition of the intervention should and should not be in place, and examine treatment integrity to verify. The descriptive statistic slope is calculated and used to provide additional information for use with your visual analysis of trend. You may use function capabilities in Excel to efficiently calculate the slope. The descriptive statistic standard error of slope is calculated and used as additional information with your visual analysis of slope and stability. Again, you may use functional capabilities in Excel to efficiently calculate standard error of slope. Last, we introduced stability. Stability, sometimes referred to as variability, refers to the degree or range of scores around a mean or trend line. Variability is the frequency and extent to which multiple, repeated measures of a single behavior yield different outcomes. When graphed, variability is readily apparent when data points do not consistently fall within a narrow range of values without a clear trend. When examining stability, the first guiding question, is my student's behavior stable, prompts you to look at the degree of variability of the student's behavior. That is, how much bounce is observed. The first example, yellow, shows relatively stable data with very little bounce. All of the data fall within a very narrow range between 23 and 30 units. The second example, red, shows much more variability in the data. It has a lot of bounce. Data scores range between 3 and 90 units. In a classroom setting, variable behavior can be quite challenging, as it is difficult to predict when various behaviors will occur. Monitoring changes in stability within a condition allows you to see whether or not something is changing within the condition. In this example, something is making student performance more variable with a slight increasing trend. A high degree of variability will indicate that you should consider what else might be impacting the behavior. Examine treatment integrity. Is the intervention happening as designed? Are there variables present other than the intervention, such as patterns around days of the week, medication, custodial issues, sleep deprivation, changes in the social context of the class? When conducting a functional assessment, some of these variables may have been discussed or considered. You may look back at the functional assessment data, interviews with the teacher, parent, or student, ABC data, informal observations, and classroom Tier 1 practices. Here is an example of an immediate change in stability across conditions. In A1, or baseline, the data are variable, with a lot of bounce and no clear trend. With the introduction of the intervention in B1, the data path stabilizes. The level also improves, and there is a flat trend. When examining stability, also consider the level and trend. So far, we have presented three basic properties of graph data that are used for conducting visual analysis: level, trend, and stability. In the final section, we offer a few guiding questions for putting it all together to help inform phase change decisions. The guidelines presented are a guide and should not be viewed as absolute or inflexible rules for interpreting graphic data or making phase change decisions, but as a general guiding principles to help inform and support educators' phase change decision-making. Educators should also consider the individual student, the context of the classroom, the designed intervention, as well as ethical considerations when making phase changes. Baseline data indicate present levels of the behavior of interest before the intervention is introduced. The logic of the baseline phase is to establish current levels of performance and determine if an intervention is needed. Therefore, the baseline data should be somewhat predictable in their pattern, stable, show a non-therapeutic trend, that is a non-desired direction, and at a level indicating a need for intervention. Two guiding questions for deciding when to change phases from baseline to intervention are: 1. Is the behavior improving? 2. Is the behavior predictable? Generally, 3 to 5 data points are needed to establish level, trend, and stability for answering these questions. When sufficient data have been gathered and graphed, the property of the visual analysis will guide your decision about the need for intervention. If data are somewhat predictable, your decision may be supported to introduce the next phase, such as B1, or intervention. When visually inspecting the first intervention phase, you will again examine level, trend, and stability to determine if data show indication of improvement. That is, the behavior is moving in the therapeutic direction and improving through level and/or trend and stability. Again, monitor the degree to which the behavior is predictable in its pattern. That is, the data are relatively stable, a good indication of experimental control. The intervention is affecting the behavior, used to establish a functional relation between the intervention and the occurrence of the behavior of interest. Again, we ask the same two guiding questions for making a phase change decision. 1. Is the behavior improving? 2. Is the behavior predictable? When sufficient data have been gathered, at least 3 data points, visual analysis shows indication of improvement, and data are somewhat predictable, you have support for deciding to change the phase by withdrawing the intervention to confirm that the intervention was the variable affecting the change for ABAB design. If the behavior is not improving, examine treatment integrity and intervention plan. For issues of treatment integrity, consider reteaching or coaching. If the plan is in place as designed, the function or method of a component of the intervention package may need revisiting. Consider confirmed intervention tactics match the hypothesized function. Then decide if the intervention needs a slight revision. If so, introduce B1 prime, or perhaps a new intervention will be needed to be designed and put in place, C1. Draw a phase change line to indicate a change in the intervention, whether it's a B1 prime or C1. A gentle reminder to avoid phase changes immediately before and after a break in school. When examining your withdrawal phase, visually inspect the data in that phase and examine level, trend, and stability to determine if present levels show some indication of deterioration, that is, a return toward previous baseline levels. Again, monitor the degree to which the data of the behavior are predictable in their pattern and ask the following 2 questions. 1. Is the behavior deteriorating? 2. Is the behavior predictable? When sufficient data have been gathered, at least 3 data points, and visual analysis shows some indication of deterioration and the data are somewhat predictable, you have support for deciding to change phases and to reintroduce the intervention for ABAB design. If the behavior is not deteriorating, examine treatment integrity to determine what, if any, intervention elements are still in place. It may be that the student has learned the new behavior and is accessing natural reinforcements in the environment, or that the intervention was not completely removed. And, as always, we recommend avoiding a phase change immediately before or after a break in school. In this presentation, we introduced ABAB, or withdrawal design, and 3 basic properties of data that are analyzed when conducting visual analysis: level, trend, and stability. When employing visual analysis to guide phase change decisions, there are no hard and fast rules. Rather, you'll generally consider the number of data points plotted within a condition and number these basic properties that change between adjacent conditions. This includes level stability and level change within and across conditions, and trend direction, trend stability, and changes in trend within and across conditions. This information is presented to support and inform your work with students, and evaluating the intervention is part of the design, implementation, and evaluation of functional assessment-based intervention. We encourage you to examine other sources of information to support your decision-making, such as information provided on BACB.com with careful attention to ethical considerations.